Hey everyone, so in this video I'm going to go over lesson 9, which was factoring trinomials where the a value is not equal to 1. So the first step for this process would be putting the quadratic expression into standard form. So meaning that the highest powers are first and then it follows through. So for our first example, I do have my highest powers here. It goes 2, 1, and technically 0 because there's no x here. Then they want you to find the product of a and c. So before I even move to the second part of this, I'm going to find the products of a and c. And in this polynomial, a is here, b is here, and c is here. So a is 5 and c is 2. So 5 times 2 is 10. Once you find that product of a and c, then you're going to determine what two factors will also combine to make the b term. So I want to become 7. Okay, I want to become that 7. So I'm going to split 10 so that I get that 7. The factors of 10 are 5 and 2, or 1 and 10. The ones that make 7 are 5 and 2. So what I am going to do is split 7 into 5x and 2x because I did the 5 times 2. Now, you're going to want to put the 5 and 2 that they need to go with a side that has like a GCF, because ultimately we're going to use factor by grouping to actually solve these types of factoring problems. So I know that I have 5x squared right now on the left side, and I'm going to move that 5, split that 7 into 5 and 2 by putting the 5 here first and then the 2x here next. And then I just dropped down this, and this just got rewritten. All I did was change the 7x and split it. Now this is all okay to do because we are keeping 7x technically. We're just splitting it into two things. Remember, when you add like terms, you would just get back to 7x. So really you did nothing to change the problem. You just manipulated the problem. So now what is really nice about this is we're just going to go ahead and factor by grouping, which we know how to do already. So while I factor by grouping this, I'm going to look at the left side, pull out a GCF of 5x. When I do that, I'm left with just x here, and then I'm left with 1 here because they both cancel. Now I want x plus 1 on the right, and the GCF on the right is 2. It goes into both things, so I'm going to pull out that positive 2, and I'm left with x plus 1. And again, look, there's your binomial GCF. I'm going to pull that out. Because I pulled that out, I'm only left with 5x plus 2. And that is how you factor this. Next one, same idea. So I'm going to make sure that my polynomial is in standard form, which it is. A squared's up here, and a to the first is here, and a to the 0 is technically there. Then what I will do is I will take a and c, and I will multiply them. So 2 times 20 is 40. I'm going to list my factors of 40. So 40 is 4 and 10, 8 and 5, 1 and 40 obviously. So I know there might be a few more, but I already see which ones that I need. I need the 8 and the 5. I need 8 and 5 because they do equal 13. And remember, your goal is for the factors to add to your b term. In this case, you want to add to a negative 13. So kind of like factoring trinomials, you want your signs to be the same so that they add up to that negative 13. So when I rewrite this and split this up, I'm going to first off write the 2a squared, bring that down. I want to pick a number that goes with 2a squared, meaning like it would have a GCF. 8 would have that GCF, so negative 8a. So like this got split up into negative 8a, and now I'm going to put the negative 5a here plus 20. So I hope you guys are realizing that when I split 13 up, it's okay because I'm doing the 2 times 20, getting those factors, and making sure they add to 13. And I am also trying to be mindful of putting that, like splitting that up so that this side will have a GCF and this side will have a GCF so I can proceed with factor by grouping. Alright, so this will split. I'm going to pull out a 2a out of the first two terms. When I do that, I'm left with just a here, 2a here. I'm left with a negative 4 because these cancel and you get negative 4. Alright, so I want a minus 4 on the right side. On the right side, I notice that there is a 5 that can be taken out. So I'm going to pull out that 5. But when I divide by 5 right now, I will get a negative a and a positive 4. But I want a minus 4. So instead of pulling out a positive 5, I'm going to pull out a negative 5. What that will do is cancel out the negatives to get me just a, and cancel this out and make it a negative 4, because 20 divided by a negative 5 is that negative 4. Okay, so now I see I have my binomial GCF. I'm going to pull that out, a minus 4, and because I took it out, it's gone, and I'm left with 2a minus 5. And that's my factoring. With the next problem, I just want to remind everyone that the first thing you should always think of with a problem is GCF. And actually, with this problem, you can take out a GCF first. And if you can do that, do it, because it'll make your life easier in the end. And if you notice, with this trinomial, there is a GCF of 2. So before I even start, I'm going to take out a GCF of 2 out of all 3 terms. That'll be leaving me with 6a squared plus a minus 2. Okay, so now at this point you have a trinomial on the inside that has an a value that is not 1 and a 2 on the outside. Now the 2 is done. I'm just going to keep bringing him down through the factorization in my, even in my final step, because he is a part of the answer. And then I'm going to take care of the inside now and try to factor this. My a value is not 1, so I'm going to go ahead and do this new method of multiplying the first term by the last term and then trying to get the middle term. Now this problem is different in 2 ways. First off, it has a GCF, which we took care of. And second off, when I multiply a and c 6 times a negative 2, I end up getting a negative 12, which is a little bit different because now the signs will be different when I separate them into factors, because you need to multiply to a negative. I want to add to a positive 1. So the factors of 12 that I can use are 6 and negative 2, or negative 6 and positive 2. These do not work because no matter the combination of me adding them, they will not get 1. So let's think of other factors of 12. We have 3 and negative 4, or negative 3 and positive 4. Again, I want to add to a positive 1 because that is my B term. And the combination that will work right now is the negative 3 and the positive 4. So right now I'm going to drop down that 2 because he is part of my answer. I am going to split a. So I'm going to keep 6a squared, but I'm just going to split the 1a into a positive 4a and a minus 3a, and then bring down that negative 2. Now what is good here is that I do have the possibility of pulling out a GCF over here. Now actually with this problem it would not have mattered where I put it because 3 does have a GCF with 6, but the way that I did it, I'm going to keep it the way I did so that we keep it consistent. I did put this here. So I'm going to drop down that 2 again, and I'm going to pull out a GCF now. So out of 6a squared and 4a, I have a GCF of 2a. I'd be left with 3a plus 2. Now, if you look at the right side now, I have negative 3a minus 2. To get that 3a plus 2 that I have, what I'm going to take out is a negative 1. If I take out a negative 1 from both of these, it'll make it positive. So it'll be positive 3a plus 2, and boom, there's your binomial GCF. That's what we wanted. So, just like I did with the other problem, well, just as I've been doing with this problem, I'm going to drop down this 2. I'm going to pull out that 3a plus 2, so they're gone now, and you're left with 2a minus 1. And everything is connected by multiplication because, again, when you factor, you're breaking down into factors. Factors are the multiples that get to your number. So everything is connected by multiplication, and if I did multiply this out, I would get to where I started. Alright, I hope this video helped you guys on factoring trinomials where a is not 1. Remember, you need to use factor by grouping in order to do this process, but you have to first multiply a and c to do that. Alright, so I hope you guys enjoyed this video, and I'll see you guys soon.